Right, so good afternoon, good day, everyone, and welcome to a new edition of the CRA Mondays. Today we have with us Stefan Benik, founder of SignPath GmbH and the director of SignPath Foundation. He will be speaking today about open source software provenance and code signing and how SignPath Foundation guarantees software integrity for its members' projects. So, Stefan, over to you.
Thank you. So hi, I'm Stefan, and I want to introduce SignPath Foundation to you today. Give you a little bit of background of what we're doing, how we are doing it, why we are doing it, the challenges we found on our way, and how we think, how we solve them, and how we think that eventually the entire open source community should maybe or could maybe be improved by applying some of the lessons that we've learned. That's not asking too much. So let's get right into it. Yeah, so Hannah already introduced me. I'm both the founder of SignPath GmbH, the company that provides the product that we're using in SignPath Foundation. I'm also the director of SignPath Foundation, which basically means that I was the one filling in the paperwork to incorporate SignPath Foundation. And the SignPath Foundation isn't really much of a foundation. It's basically a name that we use to provide certain services to the open source community, but it doesn't have any staff or nothing like that. It's just some people at SignPath dedicating some time to the activities, and it's fully funded by SignPath too. It's not really an open source foundation in the sense that it's community driven, which doesn't mean that we don't want to go there. I think we're on a good trajectory right now to since the foundation is growing, at least in terms of projects that we're supporting. I think we're in a good way to eventually have a community that some people will hopefully step up to say, okay, we actually want to put some life into this foundation and have a more community-driven approach here to what we're doing. But right now, yeah, it's just us. It's just a company doing open source stuff for the open source community. So SignPath Foundation is not a foundation like Eclipse or Apache or like Mozilla Foundation where we host our own projects. It's more or less meant to be a fallback for those projects that are not members of a foundation, but still want to enjoy some of the services that you would get by being a member project of something like Eclipse Foundation. We have started in end of 2019. Back then, we only supported, at least for our open source projects, we only supported a very obscure CI system called AppWeyer. Background is that most of our clients are Windows projects, or at least are using SignPath and SignPath Foundation for the Windows builds of their projects. And back then, AppWeyer was like the most beloved open source for Windows CI/CD system, where free to use and that kind of stuff for open source projects. But of course, pretty soon GitHub Actions came and took over that position. We haven't had a focus on that for some years. So while we did support GitHub Actions in the product, we didn't have support for open source projects in GitHub. That came in 2024. And since then, we have had quite some growth, and we grew from, I think, 50 to 250 projects alone this year. It's mostly word of mouth, people asking in forums and getting directed to us. And the initial question is always, how can we get our stuff signed, right? So lots of projects in the meantime. So what SignPath Foundation is really about is we want to solve, on a very high level, we want to work on solving the problem of safe distribution, of secure distribution for OSS projects. I think everybody knows Linus's law, like 1 million eyeballs will not miss a single bug and everything. So the entire open source security idea is basically founded in everything being open, everything being visible to everybody. So if everybody can review the source code, it will be pretty hard to hide anything malicious in there, right? And of course, we know that this is not the full story, and you still need automation and I don't know, security scanners and what have you to just be able to process the volume of code that's there in open source. But we are looking at something else. We're looking at another problem, and that's there is a disconnect between what everybody is developing in open source projects and the code that they're writing and the code that everybody can review, and what eventually gets distributed to users. And of course, if you look at the Linux ecosystem, there's processes in there that will guarantee some kind of, multiple eyeballs, at least in this process, where you have trusted packagers and these kind of processes. They seem to mostly work. But if you're looking at the Windows ecosystem, and that's really the one that we're focusing on here, or that started out with focusing on. We don't have this. We don't have this kind of system where people will automatically review and automatically ensure that they know what source code they are using and shipping to the customer. So as a user, you will basically just download from URLs and from websites. Sometimes it's, it's projectname.org. Sometimes it's straight from GitHub. But even if you download it from GitHub, you don't really know what's on there, right? So it's really in the hands of the maintainers to create packages and to distribute them. So what we want to make, what we don't want to contribute is we want to make sure that these packages, these binary packages, it's not always binary, but mostly are safe to use, and that it's easy for the customers, for the users to detect. So if you're looking at Windows, the way to do this is code signing. Windows will look at code signatures and the certificates that are used for these signatures, and will eventually make a decision whether it wants to warn the user not to install something, or not to start something, or just silently obey and just start the program or install the program. And one of the problems for open source projects is it's really not easy to get a certificate and to do the key management for some kind of open source for code signing for Windows. So we really want to have major platform support here. We don't want to have just our own breed of code signing where you can use our tools or maybe just the paths of trust that we define. We want to just work, and a user that downloads an open source project just be safe. To assume that it's safe to use as long as Windows doesn't complain. And to do this, we want to close this gap between the source codes, the source code that's hopefully being reviewed, and the actual package that's being distributed. So we embarked on this journey to find out how far we can actually take this idea and how much security we can apply here in a way that we can actually support. Like we're not this big foundation with a big application process for member projects and incubation and what have you. We're not looking over their shoulders. We're not managing their systems. We're not even asking for admission into their configurations or something. We don't have any admin level control over the projects. We just have to find a way to just ensure that they are doing well, so that we can provide the signatures that will satisfy both the Windows and the security demands of the users. So the first thing that we do is when a project applies, we have some admission criteria. So if there's an open source program, we'll check that it's an open source license, of course. That's like the criteria for being free to use. But we will also look at is there an active team? Is the project under active maintenance? Does it have a significant user base, or is it just, was it just launched and maybe we don't want to go there yet? We're demanding a certain level of documentation, like users should be able to find out what the product does, what the tool does before they started. If there is any data transfer to some predefined servers involved, something like that, there has to be terms of service privacy policy, that kind of stuff. And there's other criteria, like we actually there's a whole list if you want to see that, where we can we're basically asking our projects to to accept some criteria like no hacking tools, for instance, right? Sometimes it may make sense to sign these things because they're being used and we don't want them to be containing any malicious code, but it's not something that we dare to do because hacking tools might be used for something nefarious and we don't want to have our signature on that. So there's that kind of rules, right? And another rule is that there has to be some level of control over dependencies. Like if you are just shipping an installer for some other project and we cannot control that other project, this is not good enough. If we cannot control the actual code that goes in there, we cannot be those that sign it. But there's always edge cases, and that's one of the big problems that's basically unsolved. Is like, what if I have this one open source dependency that's not been verified? Right. So now you can argue, well, it's just one little dependency. You could also argue that the entire thing is not safe if it contains one single bit that hasn't been verifiable. So taking this idea up the dependency tree is going to be a big issue for us going forward, but it's a bit of science fiction. We're not quite there yet. We don't have the infrastructure, and even if we ask our member projects to go upstream and ask for the same level of trust that they can provide to us. It's kind of, well, yeah, but what if I have free? What if they don't care? It's not really manageable right now, right? One thing that we strictly demand, though, is it has to be in hosted development. So if somebody is just hosting on SourceForge and downloading source code building on their PC, we're not interested in that. We cannot sign this. We have to be sure that anybody who reviews the source code can trust that the reviewed source code is actually what's going to the packages. And we have to be able to verify that nothing but the published source code and the version source code goes into these builds. That's for programs. If you're just creating open source components and you want those have signed, we kind of relax the criteria because we say, okay, we still want to be able to ensure, or we need to ensure the package consumers that this connection between source code and the binary has been verified. But anything else, these libraries and components, they're used by developers and they should be able to do their own vetting of the components that they use. They should be able to decide what third-party codes to use, and we're just providing the technical guarantees that they can rely on. That's from the source code that I was able to review, not something else. So for programs, we're doing some initial vetting in SignPath Foundation, and that means that if you install these programs, you can have a certain trust that we have looked at those in the beginning, at least initially. For open source components, it's up to the developers using them. But in both cases, we need to be able to verify what has been going on during the build. So what does this mean? First, it has to be on a hosted development. If you're just hosting your local Jenkins or whatever, we cannot look into that. We won't be able to verify anything there, so we cannot accept those. So for other customers, that might be fine. For open source projects, we cannot allow this if we provide the code signing. So I mentioned already, GitHub Actions is currently our big open source offering. We're pretty soon going to add GitLab to that. Azure DevHub, so technically we can do it, but there's not much open source stuff going on there, so maybe not. In terms of reviews, what we guarantee is that if we sign something, it has to be from a certain branch or maybe from a branch pattern, like it has to be a release branch. It cannot be a feature branch because it doesn't make any sense to have review policies and then build something from a feature branch that probably nobody has ever been reviewing, and it would be easy to hide something in there. So that can't be allowed. And also we require certain branch protections to make sure that there is an uninterrupted chain of reviewable commits, and then you cannot just smuggle anything in there using your repository's admin permissions or what have you. And we're also guaranteeing and verifying build integrity. So it has to be an hosted agent. Like if you're using GitHub with self-hosted agents, that's not something that we can vouch for, right? We're verifying that the artifacts that we're signing, the programs, the installs, the packages, what have you, are actually the result of the build process that we have verified. And we are basically implementing, from the build side, we're basically implementing the criteria from SLSA level 3. If you have seen or heard of them before, that's mostly what we're doing here. So let me give you a very quick overview about one of the projects that we're currently onboarding. I picked this for a reason that you will see in a second. So from the project's perspective, from the maintainer's perspective, this is how they can use SignPath. They can have like their own configuration options here. They can define how the artifacts look like. But some things they cannot modify, like they cannot define like what branches are allowed here. In this case, they're not fully onboarded, but eventually this will probably say main or some other pattern that we have to agree on, and they have to document so that their reviewers will know what to review. And if I'm looking at so this is the project website, right? So whoever's going to review can just go away and look at the source code changes here, and that's also one of the reasons why we assume or require a certain amount of team activity and users, because if nobody cares, nobody's going to review, then it's probably all moot. So there has to be some activity here. So let's look at one of their releases. Right. From the perspective of SignPath, this is a signing request, so it's a result of one of their releases, and we're just gathering all this data and we're verifying it. So we're not just relying on what somebody gives us through some, with an API token or something, but we're really going back to GitHub and saying, okay, GitHub, we know and trust GitHub.com. Right, we have to trust something eventually, and we're just going to GitHub and asking through its web APIs what's really been going on there. Is this really the build process that it's supposed to be? Is this artifact actually what has been built in that process? What's the source code? What's the all the settings that we have policies on? What were they set to, and does this meet the requirements that we have? And by doing all these checks for every single build, we can just guarantee that the project is of the provenance that was initially negotiated with the project team. So all the other things, the initial, like, does it have any user base or something? This is a one-off thing. But once we have the project onboarded, these checks that I just mentioned are being done automatically for every build. There's a short look at the watch. I keep this short. So the 2024 XZ Utils attack was a pretty good example of what we're trying to avoid here. So that was detected over the Easter holidays by some Microsoft guy who was, I don't know, bored and just did some research into some timing obscurity with one of the libraries that he was using. That was XZ Utils, a compression library that's basically everywhere in the Linux and Mac OS and embedded world. It's just packaged into everything. And it turned out that the project was basically being taken over by presumably Chinese hacker, we don't really know, who social engineered his way into the maintenance team. So ended up being one of the maintainers, and he was able to put some malicious payload into that package before delivering it to all the downstream packages and maintainers. And he did this because, as a maintainer, he was just in control of the GPG key. And he could just sign whatever he wanted, and nobody would ever be able to detect the problem in the source code because it wasn't there. It was only on his build machine, and he signed it. So that's one of the problems that you have here. This that was mentioning initially. The open source process doesn't really, in and by itself, have any mechanisms to ensure the safety or the conformance with the source code of anything that's being delivered. And in that case, it wasn't even a binary package. It was a source package, but still it was a package, and nobody verified 100% that was exactly the same as in the source code repository. And what SignPath Foundation does using the SignPath software is basically it has to be on a managed build system. In the case of SignPath Foundation, one that we have approved, and we're just going to verify all the data that we can get from there, and to do something like what has happened with XZ Utils, somebody would have to actually build that hack into the source code or into the build scripts, which are also required to be version controlled. So it's something that with a good enough review process would have been found. Let me just skip that one. So this is how we verify what's going on the process side and on the build process side, especially, and with the source code chain of reviewability. Once we have verified that, we're looking at the actual build artifacts because we want to sign them. So we're doing a malware check. It's not optional. And then we're investigating and eventually, hopefully, signing the entire package. So one of the things that we do is nested signing. And I'll give you an example here. Again, from this project, this is the artifact configuration of Rightopia, one of the open source projects that's currently onboarding. And what they have in every release, and they're specifying that here, is let me zoom in a bit, is they have an MSI file, a Windows installer for every release. But this MSI file in turn contains other stuff. So specifically contains the exe file of the program, but it also contains like half of Eclipse runtime and or something along those lines, you tell me. And we want to have those signed too. And in one of the jar files, there is a JNI library that they also wanted to sign, right? So we can basically look at everything that's in the installer. We can check all the criteria here, like is the file name correct, is the product name correct, etc. And then we can sign these things inside out. So eventually we will repackage the MSI files and then sign the MSI file with all the signed files inside. For other files, we don't want to sign them. We just want to verify the existing signatures. Like there are some Microsoft components in there. We will just check that they're from Microsoft and are properly signed. Same goes for some files from the Eclipse Foundation. We will just check the existing signatures so that nothing unsigned can be smuggled into the package. So that's that. We have some structural criteria. We're checking existing signatures, and then we're just doing the nested signing thing for the entire package. And it doesn't matter if it's Java stuff containing Windows stuff or the other way around. It's installers or package formats. We just support basically everything that's going on there. We're supporting a lot of platforms. To be honest, most of it is currently happening on the Windows platform. So the Windows platform has its own complexities. It's not just XEs and DLLs. There's also, like I just showed you MSI, there's MSIX and Apex, and there's NuGet, which is a whole different story. So all kinds of stuff going on Windows. And that's what most of the projects are currently using. Simply because Windows will complain if it's not signed, right? And of course, we're trying to get everybody to understand that, and I think the XZ Utils example was a good case for that. We have the same problem basically everywhere, but we don't have the enforcement. Like if you download a Java server component, by default, Java is not going to check the signatures. You would have to modify the policy to make sure that the code signing actually gets effective. It's becoming a bit more common with containers. We're still not there, but we just hope that eventually the community will pick up on all these platforms and the code signing will become a standard thing, no matter what the actual platform or the subscription format is. We're also doing self-provenance signing and attestations. So we're doing our own thing here. But self is a whole separate talk probably, so I'll not go too deep into that, but we can do it. And we also have the capability to sign everything from arbitrary files, like just put a GPG or X509 based signature on that file in a detached file, what have you. Signing SBOMs is an interesting use case, or becoming one quickly too. Right. So some of the challenges that we have in code signing and that everybody's facing, especially open source project, is you have to have some things here is, and the one thing that, let's say, the ecosystem, the web PKI ecosystem. Now that's the same ecosystem that issues like SSL, TLS certificates, right? What they are focusing on is basically identity and key security. So let me start with key security. For code signing, the rules in the X509 world are very much stronger than those for HTTPS, SSL, etc. By saying the key has to be on hardware. It has to be on a specific hardware that will never give it away. So if you have a key on a hardware security module, you cannot ask the hardware security module to give you a copy of the key. You can only ask it to give you a signature based on that key. Assuming that nobody steals your HSM, the key cannot be stolen. And that's very much still the state of technology and security requirements that we have here. And there's two things to that. One is difficult for open source projects to find a good place to have secure key storage and still have it available for all the release processes for all the team members to work with. This is a thing that's slowly getting used mostly through cloud HSMs and cloud key management services. And the other one is to get a certificate in the first place. Before we get there, another thing that we have, if we're just solving the problems of keys being stolen, we're basically neglecting any other risks that we have there. And most code signing procedures, they don't really care about what you do, or how you sign your files. It's just basically somebody calculates a hash code. You just do this on your own time in your own build process using your tools, whatever. You just send a hash code over the wire, get a signature back. So we think this is absolutely not enough, especially when we're talking about open source communities. We have to have more insight into what's going on there. We have to know what's being signed. We have to have some traceability of that. Some ways to restrict what's being signed. It cannot just be, give somebody an API token and they can use that API token to sign whatever they want. You would have the same problem as with somebody having a local TPG key, as in the XZ Utils incident. It's just, if you just have a token, nobody will be able to take the key away from you, but who knows what happens with the token? That's just not enough. So the last problem that we have with code signing is certificate authorities. If you want to sign your application for Windows, especially with an X509 certificate, you have to get a trusted X509 certificate, which means you have to go to one of those certificates authorities like GlobalSign, which we're using, or Sactico or DigiCert, and prove to them your identity. Let them vet you, and there will be, I don't know, faxes of passports and phone calls and all kinds of stuff, if you're even eligible. You cannot have an open source project vetted. You have to have some incorporated organization. Sometimes it can be a private person, which is kind of a pain in the backside, because now you have this certificate bound to this one person and this name. And for the users, it's kind of, if they would really look at the signature, it's like, okay, so I don't know, Ben, whoever signed this, what does this tell me? So these are the problems that we're facing, and especially that open source projects are facing when they're thinking about signing their code in the X509 WebPKI ecosystem. With SignPath, well, I already told you how we're technically solving the signing problem. Now let's get to how we issue certificates. So we have a partnership with GlobalSign, which is one of the big global certificate authorities. So they will just give us free access, thank you GlobalSign, to certificates for code for open source projects. One prerequisite is that it has to be issued to SignPath Foundation. That solves two problems. One is that there has to be an incorporated organization that's being issued to, and the other one is that we don't have to have a certificate vetting for every single project that's going on. They all get a certificate with our name on it. That's the only way to do it, or the only way that we have found. But they are still individual certificates. So every project gets their own certificate, which basically means that they have their own certificate ID. So if you do something like certificate pinning, which in practice nobody really does, you could just pin it to that one certificate. More importantly, if we find out that one of these projects is misbehaving, we can revoke this in their individual certificate without affecting all the other projects. So right, if a project applies for SignPath, first we are vetting their general posture, like active committers and that kind of. Is there some community trust into that project already? Then we help them with the integration. There's usually one or two service support I don't know, emails, something like that. And when they fully onboarded and did their integration part, then we will issue a certificate to them. And yeah, I just mentioned they basically all look the same. The details are different, but they basically all say issue to SignPath Foundation. So that's basically where am I? Oh, I was much faster than I expected to. So maybe before we go into the Q&A, let me maybe just give you a little bit of an idea of where we want to take this, because I don't think we're quite there yet. With SignPath Foundation, we have found a way to provide open source projects with code signing certificates and the code signing mechanisms. We have found a way to make the signing safe in a way that neither through honest mistakes nor through malicious abuse can an open source project just circumvent the build process and deliver something that nobody would ever be able to see in the source code history, right? The single biggest problem that we still have is dependencies, upstream dependencies. So I kind of already mentioned this. It's if we would just say you cannot have any unsigned upstream dependencies, this just wouldn't work, right? Every project has some dependencies, especially the other open projects, open source projects, that they cannot immediately have signed in the way that they just applied to have it signed by us. We can solve the problem, especially in the Windows ecosystem. It's technically not a problem because you're basically redistributing the upstream components usually, right? So if you're just doing Windows projects like usually .NET developed software, something like that, you just have XZs and DLLs. And if you bring an upstream DLL and that has already been signed, it's easy to verify in SignPath through this system that I've just been showing you, where you can just say, okay, this is an upstream component, just verify that it's been signed, and off you go, and that's easy. It's not so easy to do this in ecosystems where the exact build result from upstream doesn't get delivered by downstream projects in exactly the same format. So just think Node.js, for instance. And there have been certain initiatives in some ecosystems, and I think Node.js is a good example. They have teamed up with GitHub basically to find a way to have sulfur attestations attached to individual npm packages. But it's very much not a solved thing in the sense that you can just define how the entire upstream chain has to be signed or tested or verified. So I think this is the single most unsolved problem in the entire open source ecosystem, to get some kind of control, some level of control, not just over the source code and build posture of one individual project in the supply chain, but you eventually want to go full in and want to find a way to basically force the entire supply chain into submission and say everything has to be signed, or else the downstream package won't be signed, meaning that certain users or customers are not going to be able to use it. And I believe this is probably where we're going with the CRA, right? Where we cannot just have an isolated view on individual projects, but we have to find a way to exchange attestations or semantically loaded signatures, if you will, like we have with SignPath, in a way that is integrated into the platforms, into the dependency management systems, etc., that can give you like a single button or a way at least to implement some single button verification of the entire thing. And now I'm opening the lines for questions. Thank you.
Thank you very much, Stefan. A really nice presentation. I don't know if any in the audience has a question. I do have. But yeah, I would like others to speak up. If no, I have one question about attestations that you mentioned. Since this is a topic that we are covering in the working group, and it's one of the main things we are trying to develop. I would like to understand what are you doing in that area, and how you foresee the attestations evolving and the fitting with the CRA obligations.
Mm-hmm. So am I still sharing? I'm somewhat used to Zoom. I'm just trying to cancel the sharing. Can somebody please tell me if I'm still sharing?
Yes,
Okay.
you're still sharing.
What do I have to press to make the share go away?
It should be towards the bottom, the end share.
Oh, or there is a bar with a green thing.
Oh yes, I moved it to the other screen. Yeah, stupid me. Stop share. There it is. I just moved it out of, and then it was gone. Yeah. Okay. Okay. So I'll just move the other screen so I can. I have it easier if I'm looking at the camera. So okay. So the question was, especially with regards to the CRA, how can we improve on things? So what we see is certain promising initiatives appearing. And I already mentioned SLSA several times. Now, the problem that I personally believe that we have with SLSA is that it explicitly doesn't include upstream, and it also doesn't focus on interoperability. Like it's a very well-defined semantic model about the criteria that have to be evaluated in order to reach a certain level. It's already there for the build system, and it's about to be released soon, we hope, for source level, and that will basically cover what I have shown you today. The problem is that there is not a single format, there is not a single verifier, there is not any way to define where to find an attestation, like in a build chain. But simple expressions of containers, which they have been focusing on. But if you say, look, I have a Java application and I have Java dependencies, so how do I define my upstream dependencies in terms of SLSA to be sure that I have an uninterrupted chain of security or trustability there? It's just undefined. So what we are doing is we're just helping individual customers with that and saying, okay, look, you have some open source dependencies. Why don't you talk to these open source projects? Maybe they want to onboard with SignPath Foundation, and then at least you will have signed components from upstream, and you don't have to worry about, do I want to sign a third-party open source component? Well, maybe I do not want to do this because then I would have to build it myself. Right, and then the thinking begins. Then okay, but I'm already distributing it with my software, so my customers are already getting the package from me. So if there is a problem, my customers already have a problem, whether I sign it or not. So this is let me say that this is a process of people actually realizing the magnitude of the problem of just using unvetted and unverified open source binaries, right? So we're starting there. We're starting with customers who say, okay, now thank you, SignPath, for helping me to get my entire internal software process under control and attested and what have you. But now I'm worrying even more about the upstream dependencies. So help me get the upstream dependencies under control. And then it turns out these upstream dependencies have upstream dependencies too. And I think this just requires a bigger effort than we can actually deliver. We're just a small company in Europe, right? We can provide experiences, we can provide opinions. We're open to participating in a wider, let's say, approach to this. We just went ahead with what we have. We just took the proprietary product that we have, tried to get some use out of this for the open source community too. But it's a completely different ball game than really, I don't know, talking or defining standards, be it in the cells or maybe in the OVAST community or what have you. So actually, we'll be very interested too to see how this all works out.
Perfect. Yeah, no, indeed. I was asking precisely because, yes, one of the things that we are pushing within the working group, I think that your views in the activities that we are developing will be super valuable because, yeah, of course, we have our different members providing how they think they should work. We have some others that have already started to define attestation programs for open source. For different open source foundations. But I think that having your view as tool builders on the topic would be also super helpful, basically to try to combine all the different inputs and generate something that it's basically as you share, it's something that can scale and will be consolidated, if not standardized, because maybe standardized at this point is a bit too much, but something that at least is interoperable, which is one of the key challenges that the CRA is bringing for sure. I don't know if anyone else has any other question. If not, I would like to say once again thank you to Stefan for his presentation, also to Florian because he was the one starting all the connections. And we're really looking forward to keep discussing attestations and all other topics within the working group. So thank you very much, all of you, for participating in our CRA Monday today. And see you soon. Thank you. Have a nice day.
Thank you.
Bye-bye.
Thank you.